Okay, so this time we're given some Verilog, and we have to draw the sequential circuit that's represented by the Verilog code. So there are some things you want to look for. There's some clues that are going to tell you how this is going to work. And you just look for those things, and that'll help you get it started, just like you may not know where to get started, and follow what I'm about to tell you, and it'll get you on your way. So first of all, you see you've got this output reg 2:0y. What that tells you is that we have a y0, a y1, and a y2. So it goes from 0 to 2, and it's like an array, sort of, kind of. It's, represents, a wire that's 3 bits wide. And so the 2:0 tells you that you have those. And then now you know that, so now you know what these things are in the rest of the code. So now always at positive edge clock. If not reset in, what that means is if you reset in means you would reset if the signal is 0. And if it is not 0, then it is resetting. I know it's bizarre. You can just kind of learn it that way. This is like the initial load. So the initial load for the reset is to load y to be 0, 1, 0. And so what that means is that when you start, let me draw my three. The three Y's here tell me that I'm going to have 3 flip-flops. And we're going to use D flip-flops. And we'll have a Q, Q, Q. This will be 2, 1, 0. And you can be pretty sure anytime you've got any kind of if statement, you're going to have a multiplexer going with each of your flip-flops. So we can go ahead and do that. 0, 1, S. These are supposed to be trapezoids.
Instead of an if statement, there's a multiplexer?
Or a case statement. Almost certainly. Almost certainly. Okay, and we have a clock. And if you're struggling with what to do, you can always do this. You can always say, okay, well, I figured out I've got my 3 values here. I know I'm going to need 3 flip-flops. There's an if. I'm going to have multiplexers. The multiplexers are always going to enter into the D. I'm going to have a clock. I can draw my clock. The clock is going to go into there. And there you have your framework, so that, you're getting somewhere just by doing that. Okay. Now, we have our reset in. So reset in is involved with our if statement. And so our reset in, that's the thing that's going into our multiplexer. Because the thing that's involved with the if statement is what goes into the multiplexer. So if not reset in, So that means if reset in is 0, then y becomes the 3-bit binary number. That's what the 3 and then the little apostrophe means, and the b is binary. The 3-bit binary number 0, 1, 0. So that means that you're just going to have 0 going into the 0 here, 1 going into the 0 here, and 0 going into the 0 there. So 0, 1, 0, this would be D0, D1, D2. Okay, so that's if reset in is 0. Else, so this is what's going to happen if reset in is not 0, or if reset in is 1. So this is where we're going to figure out what goes into the 1 inputs of our multiplexer. So what this line means right here is that y0 becomes y1 and x. Okay, so this is y0 right here, y0, and this is y. This is y1, and this is y2. I'm sorry, I'm so bad at drawing these. Okay, so y0 becomes y1 and x. So x is yet another variable that hasn't shown up yet, so we'll just make it. So we have x, and that's going to be ANDed with y1, and that goes into the 1 terminal of the multiplexer for y0. y1 becomes y0 or y2. Okay, so here's y2. Here's an OR. Here's y0. And that goes into the 1 for y1. And then x goes to y2, so x goes to y2. And let me just get y'all a better picture for all that. There's a much neater picture for it. Yes. Yes.
How do we know that it's going into like a 1 input terminal?
Okay, so that is an excellent question, and here's how we know. Let me go back to, we'll look at it right here. Okay, so it's really tricky on this one because of the variable is a strange variable. It says if not reset in. Okay, so if not reset in, that means if 0. So if reset in is 1, then not reset in is 0. So it's saying if 0, then we do that initial load. Okay, but else, and the initial load goes into, so reset in is our select. So whatever reset in is, that's what's telling you what you're going to get. So if reset in is 0, then what's coming out is going to be whatever comes into the 0 of the multiplex. So else means reset in must be 1. So this is 1 coming into the select. And so that means whatever we're putting in here, that's going to be what we want to come out when it's 1. Did that, in a muddled sort of way, answer your question?
Yeah.
Okay.